Okay, we're going to turn now to probably a much more common form of price discrimination, one that economists call third-degree price discrimination. Here are some examples where you actually segment the market and charge different prices according to whatever group you are able to divide the market into. Here's some classic examples. For instance, age. As I rapidly approach that magic Medicare number, I'm getting the opportunity to enjoy senior citizen discounts. Now, is that because people think that seniors have limited income or should be treated with respect, or it's a reward for making this far? Oh, I don't really know. I think it has probably more to do with seniors have maybe lots more time on their hands, lots more time to look and see where the best bargains are, and that they're more price sensitive. Sometimes there can be gender differentials, although that's becoming increasingly dangerous in this world. But you still see ladies' nights at some bars, and I can't the legislature hasn't gotten upset about that quite yet. But anyway, customer characteristics are one way of splitting the market. Other times, if you wanted to look at some business-to-business settings, past purchase behavior might be a way of encouraging people to re-enlist, to extend their licenses. That happens. Location might be different prices in different parts of town, or different East Coast versus West Coast. There might be very different prices charged. Certainly, if, say, you want to buy a quarter pounder from McDonald's, it is not priced the same everywhere. And again, the price differentials largely reflect, to some extent, cost differences across states, but also probably more likely demand features of the audience. And then, of course, we're going to look at more detail at this one in the next video, but there you could segment the market over time. That is, when you first introduce a product, charge a relatively high price, and then as you morph the product into different versions, you gradually cut the price. So those are all different ways of splitting up the market. Now, I want to remind you from the second video for this week, there's some basic principles that we have to follow. That is that marginal revenue needs to be the same across all markets. And then, of course, marginal revenue across all those markets has to equal marginal cost. And let's just look graphically at how this might operate. And I pulled this in from another book because I think this is cleaner and easier to understand than the diagrams in the textbook. And it's also based on a real-world example. The Cozumel Ironman takes place every year, and interestingly enough, local participants are charged a much lower entry fee than traveling participants. Now, why might that be? Well, there's a couple of reasons. One is, who lives in Cozumel versus who's flying in. There's going to be some pretty big income differences, some pretty big ability to pay differences between the two groups. Also, when you say, for a local, what is the cost of going? Well, largely it's the entry fee. That's it. But if you're flying in from New York to enter the Ironman, the entry fee, frankly, is small potatoes compared to everything else you've already committed, the flight, lodging, and the like. So that there's an extra room, shall we say, to nudge on price for out-of-town participants there. And what you see is you've got two different demand curves, and the out-of-town people, the highest price they're willing to pay is $340, and the demand curve is relatively flat. And so you see the out-of-town people paying $220 to enter, whereas the most anxious willingness to pay local participant is only going to fork over $240, and the price for the locals ends up working out to a still non-trivial $170. So this is just kind of a clean way, flat marginal cost curves, make sure that marginal cost is the same. And marginal revenue equals marginal cost in each case as well. So that's just kind of a nice clean diagram that I think really captures what you need to know about this. Now, let's think a little bit about elasticity and how that comes into play. And all I'm doing in this slide is laying out some notation. On the first formula that you see, It's just marginal revenue. This is from Monopoly last week. Marginal revenue equals price times 1 plus the inverse of elasticity of demand. Keep in mind, elasticity of demand is negative, so 1 over the inverse of it is going to be a negative number, and it's going to be a fraction because elasticity of demand is always going to be greater in absolute value than 1. So anyway, that's going to be 1 plus a negative fraction. Now, in practice, let's use that same formula and talk about marginal revenue in segment 1, and we'll call segment 1 the least elastic and segment 2 the more elastic portion of the market. Well, now I'm just rewriting the formula and saying that the marginal revenue in segment 1 is equal to the price in segment 1 times 1 plus the inverse of the elasticity of demand in that segment, and same is true for marginal revenue in segment 2. And so E1 is elasticity in segment 1, E2 is elasticity in segment 2. Okay, all I've done out here is layout notation. There's no trick up my sleeve yet. Now, in practice, we know that the marginal revenues have to equal each other and they have to equal marginal cost. So then if we equalize those two formulas, in other words, if I set P1 times 1 plus the inverse of elasticity 1, if I set that equal to P2 times 1 plus the inverse of elasticity E2, set those two equal to each other and then move terms around so that I've got the price ratio on the left side, and then I've got the ratio of the different marginal revenues on the other side. And what we see is that the price ratio is certainly going to be reflective of the elasticity ratios. Now, I'm going to admit something to you. It's probably not real easy to eyeball this formula and say, okay, what am I going to learn from this? Well, let me assert for a moment that the key takeaway is going to be that you're going to pay a higher price for the good that has the most inelastic demand. And that ought to make common sense, right? That the people that are less sensitive to price in their purchases are going to end up paying a higher price than the people that are more sensitive. There's a certain amount of common sense there. But, oh gosh, where did this formula come from? How can we make sense of that? Well, rather than pick through the formula, I mean, mathematically we could prove it, but this isn't a math BA program, it's an MBA program. So let's just plug in some numbers, and let's just suppose segment 1 has an elasticity of -3. Segment 2, the elasticity is twice as high, it's -6. So I'm just going to plug in then -6 in the numerator and -3 in the denominator. And so 1 plus the inverse of the elasticity of demand in segment 2 becomes 1 plus 1 over -6. And that's really becomes then 1 minus 1/6. And then in the denominator, what you have is 1 plus the inverse of -3. And so that's really 1 minus 1/3. Then we can, all right, the numerator is really the same as 5/6. The denominator is the same as 2/3. And then you do the calculations and, get out the calculator on your phone, and then you have 1.25. So what it turns out is that the price for group 1 should be 25% higher than the price for group 2. So that's how... and that's what we would expect, right? Group 1 is less price sensitive, so they're going to pay 25% more. You might on your own as an exercise, I'm not going to put this in a slide, but as an exercise to make sure you follow this, suppose you try elasticity in segment 1 of -2. Suppose you try elasticity in segment 2 of -4. And then plug these numbers into this formula that you see at the top of this slide. And how much more are the people in segment 1 going to pay over segment 2? You should find a 50% higher price. Okay, that wraps up third-degree price discrimination. We're next going to shift gears and look at how prices might vary over time in the same product in a single market.